Hello everyone and welcome back to the course. In today's lesson, we are going to learn how to compute the area between curves by using the concept of definite integrals. So, off we go. Let us consider two functions f of x and g of x defined in an interval a, b, such that f of x is greater than or equal than g of x for all x in the interval AB. Then if we denote by Q the region enclosed by the two functions, then the area of that region will be equal to the integral from a to b of f of x minus g of x dx. Let us consider the following example. Let us find the area between the curves defined by the functions f of x equal minus x squared plus 2x plus 1 and the function g of x equal to x cubed minus 1 on the interval 0, 1. As f of x is greater than g of x in such an interval, then for computing the area, we need to do the integral from 0 to 1 of f of x minus g of x. In this case, we have to do the integral from 0 to 1 of minus x squared plus 2x plus 1 minus x cubed minus 1. Now, if we rewrite this expression, we have to do the integral from 0 to 1 of minus x cubed minus x squared plus 2x plus 2, which is equal to minus x to the 4 divided by 4 minus x cubed divided by 3 plus x squared plus 2x, and we need to evaluate from 0 to 1. And if we do so, we get the value of 29 over 12. Now, our second example involves the function f of x equal 3 minus x squared and the function g of x equal x plus 1. This function intersect at x equal negative 2 and x equal 1. Thus, we need to do the integral from minus 2 to 1 of 3 minus x squared minus x minus 1 because the function f of x is on top of g of x in the interval minus 2 to 1. Now, if we rewrite this expression, we will be doing the integral from minus 2 to 1 of minus x squared minus x plus 2. If we solve the integral and then substitute the values from the definite integral, we get, as a result, 9 over 2. Now, if it is the case in which we're dealing with two functions in terms of y, meaning x equal f of y and x equal g of y, then computing the area between those two curves is pretty much the same in reasoning, because instead of doing the integral from a to b of f of x minus g of x dx, where f is above g, we will be doing the integral from c to d of f of y minus g of y dy, where f is to the right of g. Let us consider the functions x equal minus y plus 1 and x equal 3 minus y squared. And let us compute the area between those two curves. Now, as x equal 3 minus y squared is to the right of minus y plus 1, then we need to do the integral from c to d of 3 minus y squared plus y minus 1 dy, where c and d are the points of intersection between those two curves. If we find the points of intersection, those values are c equals negative 1 and d equals 2. Now, we have the integral from minus 1 to 2 of 3 minus y squared plus y minus 1, which is, if we simplify, the integral from minus 1 to 2 of 2 minus y squared plus y dy. Then, this result will be equal to 2y minus y cubed divided by 3 plus y squared divided by 2, which we have to evaluate from -1 to 2. And our result is equal to 9/2. As usual, it's time for you to put your knowledge into practice by computing the area between the following curves in the given interval. If the interval is not given, it means that you need to find the points of intersection between the two curves. So well guys, see you in the next lesson.